figure. I haven't done this in so long. I don't remember. So let me try to remember how you turn on the closed captioning, because I wanted to do the closed captioning while I'm talking. There used to be, like, if you hover over it, there was a bar that came up to turn on closed captioning. I don't know why I don't see it. It used to be like right here when you, what is it, BIR, and why is that there? That shouldn't be on here. We'll figure it out. Give me 1 second. We got time. So down here at the bottom, there were some notes that we put a long time ago. Those probably are no good anymore because we've now changed TAs multiple times. Maybe if I do escape, exit full screen. This is annoying me. Okay, hold on. Turn on captions on Google Slides. Open your presentation and then click View, Present, turn on, click CC. This is in the menu at the bottom of your slide. That's what I thought. Okay. So let's go back in here again. View, Present, show comment, show film strip, slideshow. That's weird. Okay, we'll figure that out later. But anyway, so we always start and we just go, welcome everyone to the Introduction to AI Robotics Workshop. I am Carlotta, or Angela, and I will be your facilitator for today. A little bit about myself is I'm a grad student at Louisiana State University, blah, 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 blah. So after that, I would go over the schedule. This is going to be a 2-hour workshop. The first 5 minutes, we do introductions of all of our teaching assistants, and then any participants who would like to come off of mute and turn on their camera and introduce themselves, we'd be happy to hear from you as well. Then we share what the mission of Black in Robotics is, and we also always want to thank our sponsors who supplemented the cost of your kits. And then we talk a little bit about what exactly robotics is. And then we go into breakout rooms and we build your robots or help you to get your robot built. Then we come in, do a check-in and a small 10-minute break, and then we go back into building and programming. We understand that people have different skill levels, so you may not all get to the end, but we try to get you as far along as possible, and you can always reach out to us later if you have questions. And then the last 10 minutes of the workshop is a wrap-up. How are we doing? Are there any questions, Cyril, Christopher, Angela, so far?
No, it's clear. That's fine. It's clear.
Okay, so then the next slide is just the introductions. I typically, Angela, you would introduce yourself first. Then you would call on all the TAs and ask them to introduce themselves. When they come into the room, I always ask them to rename themselves TA dash and their name so that it's easy to find all the TAs, first of all, especially if we're going to have 21 participants here. It may not be hard. It may be hard to find them. So you definitely want all the TAs to rename them, because then I will either do breakout rooms or I will help you to do breakout rooms, and it'll be a lot easier to do if we can quickly identify the TAs. Okay. After that, I always share the mission of Black in Robotics, the mission of Black in Robotics, blah, blah, blah. And then, as I was saying, I'm going to add a new slide here called thank you to our sponsors. We want to always share that the kits are sponsored. And then because we have so many sponsors now, what I would do for this part is I would just go and make a screenshot of the website. So if you go over here to corporate partners, I would just take a picture of this one. I'm gonna do this really quickly and just paste it in there. And then put it on the slide. And then we also have smaller sponsors. I'm gonna do this one again because that Google got kind of cut off on that one. Then we had some sponsors from before who gave money just for the kids. And so I would also continue to shout them out, even though they haven't given us any money in a while. They did. So, okay. So here's the first set. These are like the major sponsors here. And you don't have to read their names necessarily. I would just put this slide up for a second. And then over here on events, we have sponsors who have probably in the past given us something. So I'd put them there. These are like our workshop sponsors. Okay, and then I'll put that down here. See if I can get creative and figure out a way to get this all on here. It's really bugging me that I cannot get those closed captions to show up. All right, let me see if I can find a way to do this so it's not cutting anybody off. Yeah, so that's probably okay with that. Okay, so back to the slideshow. View, slideshow again. Thank you to all of our sponsors who have helped with kids, scholarships, blah, blah, blah. Okay, so the learning objectives today are to define a robot, describe parts of a robot, describe the basic robot control, electronics, and build a mobile robot. So as you're reading over the lecture, you might want to warn also that we may be recording, especially if there's children present. If there's children and no adult, I might not record because we do sometimes put our videos on YouTube. And then as you're going over the lecture, try to put some questions that they can answer in the chat so that the TAs can help them answer some questions in the chat to keep them engaged. So the first thing you have to do to build the robot out of your SparkFun Inventors Kit is you're going to make a basic circuit with a switch, an LED, and a push button. Then you're going to add your motor driver and your DC motor, and then you're going to add the sonar, the wheels, and battery pack so that you can actually use the robot. I'm going to put battery pack on here too.
Okay, got it.
Okay. And everyone should have access to these slides because I just put the link in the chat. So then I would say something like, what is a robot? And then maybe wait a second before you answer and say, type in the chat or come off of mute and tell us what you think a robot is. So let them put, they'll say a machine, whatever. It doesn't really matter, whatever they say. Then after they answer, you then go, okay, great job, all good answers. So a robot, first of all, is autonomous. So a robot can be anything from remote control, which means it has no autonomy. It can't do anything on its own without human intervention, to being fully autonomous, which means you have a robot that can do things without human intervention. So robots are normally some level of autonomy based upon what they have to do. A robot needs to have a job or a task or a mission, something to do. It has to have a body. So typically the robot's body needs to be appropriate for what you want it to do. So you might have a mobile robot with wheels. You could have a drone, which we know Cyril does drones. It could be a flying robot. It could be a vacuum cleaner, or it could be a pool cleaning, swimming robot, whatever. And it needs to have some sensors. So the sensor should be appropriate for what the robot has to do. That's how it gets its intelligence, by whether it's sonar, infrared, temperature sensor, light sensor, whatever. You might want to ask them, what are some other kind of sensors? Put in the chat if you know what a sensor is. They could say an encoder, a tachometer, a GPS sensor, an accelerometer, whatever.
Okay.
Then the robot has to act on the world. The way it acts on the world is, what does it do to impact the world? That could be the wheels that are rotating with a motor. It could have an arm or an end effector or gripper. It could have flippers, whatever the thing is that then impacts the world. And once again, it has a task or a goal, because a robot is not very interesting if it doesn't have something to do, right? Just sitting there in the middle of the floor is not very interesting. Okay, any questions so far? I've done this a million times, so that's why I can just rattle it off. But go ahead, Angela.
No, I don't have any questions. I'm good.
Okay, Christopher, you good? Cyril? Okay, so then what is a robot made of? So this ties very closely to what is a robot? So obviously it needs a brain. The robot's brain could be a microcontroller, it could be a microcomputer, it could be the Arduino, it could be Raspberry Pi, it could be MATLAB, it could be a desktop computer, whatever. So the brain is like the controller. It's the thing that the robot uses to think. Then, as we already said, it's got to have a body, and the body's got to be something. In our case, your body is simply that little that stand that holds the Arduino. So it's a very, very basic body that you're going to make with your SparkFun Inventors Kit. Then the effectors are the thing that affects the world. So like we talked about, that would be the gripper, that would be the wheels in the drone, that might be propellers or whatever. And then the actuators is the thing that gives that power. So you could have DC motors as the actuator. You could have vacuum tubes. You could have pneumatics, right? So whatever the thing is that then gives power to the effector is your actuator. And then last, we talked about the sensors, where you could have many different kinds of sensors. And the one sensor your robot has for this project is the sonar sensor. But you also have a light sensor in your kit that you could add to your robot. So we already talked about the levels of robot control. So the ones you're going to do today are remote control. So when you first build your robot with the remote control, what we do is we show you how you can press keys on your keyboard of your computer and make the robot move forward, back, left, right, etc. After we get that working, there are some semi-autonomous, which means there's a little bit of remote control and a little bit of the robot doing things on its own. You're going to make a fully autonomous robot, which means now it's just a straight obstacle avoidance robot. You are no longer trying to program it with your keys. There's no wireless connections at all. You just put a battery on it and it just drives around and uses the sonar to avoid obstacles. And the way you do this is with an Arduino Uno microcontroller. The one in your kit is red because it's called a red board, but really a red board is just really an Arduino Uno. It's just a clone. So yours should look just like this, other than it's red. It should have the digital pins 0 to 13. It should have the analog pins A0 to A5. There should be a ground, VN, etc. At this point, guys, I'm hoping that they have actually done their homework. So this part should not be foreign to them. If they've done no homework, which we unfortunately have had people show up who've done nothing before, then when you go in the breakout room, you got to start from ground zero with them. But I mean, you know, they paid for the workshop. You get out of it what you put in, so you meet them where they are. So this is the brain for your robot. We program this microcontroller and we attach things to it in order to get the robot to work. So think about what a basic electric circuit is. This is like the hello world of electronics, is to always turn on a light. And this is the first step in getting your robot working. So to turn on a light, you're going to have a battery, a resistor, and a light emitting diode. And what this does is you apply a voltage from your microcontroller on pin 13, and it makes the light blink on and off. And it does this with this resistor because if you just did it straight with 5 volts, you would burn the LED up. So by attaching this resistor here, you limit the voltage drop, you limit the current to make sure that the LED will continue to flash on and off without burning up. And you build this on something we call a proto board or a breadboard. And it gets its name because people used to actually build circuits on an actual breadboard, like from your kitchen, where you have the LED here, the battery here, and you have a switch that flips on and off to turn the LED on. And they used wires and thumbtacks to connect it all together. We don't do it on breadboards anymore. Now we actually use a proto board here where these connection points are used with the LED. You're going to see letters and numbers on your breadboard. The letters and numbers tell you where the nodes or the connecting points for the electronics are. If you were to open up your breadboard, you would see these tabs. So tabs A through E, 1A through E would be one connection point. 1F through J would be a different connection point. So what that means is that when I want things to touch on my circuit, instead of using thumbtacks like we used to, you use wires. So if I want anything to touch this LED here, I would put a wire on the same row on each side. And then I connect it to the microcontroller and that resistor that we saw in the previous slide to turn it on. How are you all doing so far?
Good.
Good. Okay. All right.
Good.
So then after you do an explanation, I always show a brief video. So here's a video that has the LEDs, the potentiometer, which is a variable resistor, and it shows how this works. Ideally, this is one of the projects they should have completed before they come. If they haven't, this is where you have to start in the breakout room. One thing is the sound is not all that important, but when we share, if you want them to hear the sound, share. There should be a button down here that says share sound. I'm still upset I cannot get this doggone closed captioning to work, but there is a, I'm gonna figure that out though in a minute because it's broken. Engineering like that. I can't figure that out. Oh, here it is. I don't know why this didn't show up before. There we go. Yay, we got closed captioning. Yay. You don't have to show the entire video. You can show as little or as much of the video as you want. The main thing is for them to understand how an electric circuit works and how the potentiometer. If they did this, because I also sent them these videos when I sent them the assignment to do before the workshop. So if they did all this, you can really go fast over there. One thing you may want to ask in the chat is how many people did their homework? And if you did your homework, how many projects did you get done? Ideally, we wanted them to get through projects 1 through 4, because I believe project 5 is the robot. And if all of them put project 4, then that's good. You can kind of speed over all this because that means they learned this stuff already.
Okay.
So I'm going to move on. So now, here are 2 examples of motors. You actually have them both in your kit. The DC motor is used to spin the wheels on the robot to get the robot to move around. Your servo motor was used for a different project, but in the future, what you could do with the servo motor, because it's a motor with electronics that moves to a precise location, you can add a cardboard arm to this and make a gripper or a pusher or something on your robot. So the DC motor spins freely and with variable speed for the wheels to move your robot, and you can use a servo motor for to add a gripper or something like to your robot. And so the program, the electronics and program for the motor controller is shown here. You're going to do it with one motor first. So this is called a motor controller or an H bridge. And basically what it does is you wire this up. Speaking of which, I wanted to mention something else that Aaron had mentioned in our first TA meeting. He said, why don't you add on the shield to the Arduino to just control the motor? I looked into that as well. The problem is that shield comes with no headers and you have to solder them. So we couldn't ship those out to participants because we would have to get them in, solder them, and remail them. And if we're talking about people who are novices, I don't think that was going to work. That's why I decided to stick with the motor controller instead of switching over to that Arduino shield. I don't know if you guys remember when Aaron mentioned that or not. Because we got to keep this simple because we don't know what level these people are. So, and I don't think it's that horrible if you walk them through wiring the motor controller step by step. As long as they don't make a mistake, it should work. So you would have to walk them through the wiring the motor controller in the breakout room and the switch. And then over here, they have code. The first code just says, if the switch is reading low, spin the motor. If the switch is not reading low, the motor should stop. This is a good beginning for getting them ready for adding 2 motors to the robot. And then we talk a little bit about what does it mean for a robot to be differential drive. Differential drive means it has 2 wheels, 2 motors, and if you want it to move a certain direction, then you have to make the motor spin forward, backwards at either the same or different speed. At this point, I would then ask questions and let them answer in the chat. Which of these 4 images represent a robot driving forward? If you think about that red dot is towards the front of the robot. Forward, you then would have to say 2 wheels going the same speed in the same direction, and that would be forward. Or 2 wheels going the same speed, same direction, but to the back, that would be reverse. So this top middle is forward, this bottom right is reverse, and I would just have them answer these questions. Once again, this is more to get them actively engaging and participating.
Got it. Okay.
Thank you, Christopher. I just saw your note. Christopher was saying he's having network challenges, but he's still here. Next is a sensor. We talked about the sonar sensor is like the robot's eyes because it's used to detect the distance to objects or the presence of an object. And the way that it works is with sound. It uses the Doppler effect in order to do a ping or a chirp and then to listen for the echo for navigation. And then I always ask this question because it's an easy one. What 2 animals do we know that use the Doppler effect to do navigation like our robot will? And then I let them answer in the chat, and the answer is always dolphins and bats. So dolphins and bats also use sonar for navigation. And so then I would go on to, now we are ready to build our fully autonomous obstacle avoidance robot. So now we're going to add the second motor to the motor driver, and we're going to add the sonar to detect distances, and we're going to have the switch there for turning the robot on and off. After you help them get it wired up in the breakout room, you have them open up the code. And the good thing, this code is already written. They just have to open it up, and I would walk through it with them and make sure they understand it, but they don't have to write it. They can modify it later if they want to change something. So they're going to read the distance from the sonar and then make sure that their switch is low so that the robot is turned on. And if the distance is less than 10, the robot should stop and back up and turn away from the obstacle. If the distance is greater than 10, then the robot should just drive forward straight ahead. Some thoughts about how you could modify this code is instead of the robot stopping and turning and spinning, you could change the speed at which it stops, the speed at which it turns, the way in which it turns. So have them run the code as is. And then if they want to talk about upgrading, have them maybe change the number or something in here and see how does the behavior of the robot change if you modify the code. So here's some basic videos I made of getting the motors working. If they've already done this, you can skip. If not, show them a little bit of this as well. I'm speeding this up. So this is the sonar. So this is the one that goes to precise location, like the one you could use for your gripper. That's the photoresistor or a light sensor that I'm using to control the motor. That's something else you can add to your robot. Okay. This is the sonar, the LED, and a buzzer. So once you get your robot working, you can add an LED and a buzzer as well. And here, based upon the distance, you see that the LED light changes color. Okay. Hold on. So let's look at what should happen now that you are ready to do project 5 and get your robot built. You're going to do this in the breakout rooms. And so the only thing I forgot to put in here is the brakes. So I think I'm going to modify the slides after this so we can actually insert the brakes into the slides so you'll know at what point to stop. Let's see how long I've been talking. I've probably been talking about 30 minutes so far.
Carlotta, this is where we can start going into the breakout rooms when we get to this slide.
Yep. So after this slide, let's do a breakout room. So let me see, how long did I say I wanted that first break to be? Lecture 20 minutes, 30-minute robot build, check-in break. Okay, so let's do a 30-minute robot build after this slide, and then we'll come back and do a little bit more instruction. We'll do a check-in.
Okay.
Yep, so I'm going to add a slide here. Oops, I didn't want to do that. We want it to be like this slide. After that one, we're going to do 30-minute robot build. And then after that, then we do 10-minute check-in/break. Okay. So then they're going to come back and maybe there's only 2 slides left. So I think maybe we'll do these next 2 slides at that point. So then this one is just, now let's make sure you wrap up your obstacle avoidance. So this is an example of what it looks like when it's all done and working.
Okay.
So it's just driving. And show that it should stop and avoid whatever. Okay. And then, oops, then the final slide is, let's say you have now gotten your robot working. What are some things you can do next? And if you're going to go back in the breakout rooms and either get your robot to do the autonomous, you can now add a sound, you can add buzzer, you can add lights, etc. Let me go to this next slide. Then once you get that working, you can even add a photo resistor and show how you can do light tracking with your robot. You can use your cell phone light with a photo resistor and now use that to turn towards the light and track the light, etc. And so then after that, we're going to do another 30-minute breakout session. And when they come back from that one, that's going to be wrap up. So let me make sure. I said 40 minutes, but I put 30, whatever. It kind of depends. Depends on how long it takes. So that'll be our second break build. There's not going to be a break after that one though. So we're going to delete this 30-minute robot build. And then when they come back from that, everybody, there will be a 10-minute check-in though. And once everybody shares their check-in, we wrap up. We just say thank you for coming. We'll put thank you here. Nobody ever does this, but I'm not going to give up on it. Well, you did. Angela and Cyril, you do, but I could really take our team on Twitter off, but share your project on social media. Let me fix this. Why this is so weird looking. I think it's a different font, maybe. All right, and I think that's it. Is there anything I'm missing that you think we need to talk about? We don't do surveys anymore because I just don't care. I mean, you know, honey, I'm living just enough for the city. So I'm taking all that off. I'm gonna hide this slide. Skip slide. Anything else? Any questions you have? Anything you think we need to add to the slides? Anything you think we need to discuss?
Okay, so like how long does this session go for? Like, because I know from the calendar, it stated that it's on the 16th of July, but for some reasons, I'm surprised it's also holding today. So why if I noticed it's 16th from the email. So, but I was shocked that you're also having a session today. So are we having another session by 16th?
Yes. So next week's session is for the participants. There's 21 people coming to the workshop. This workshop today was really to help the TAs for people who've never done this before, but they didn't come. So.
Oh, okay. I get it.
So because of that, that means next week I'm going to be looking for you and Angela and me to be the primary contacts. Just to make sure, because I think we're going to have a lot of rookie TAs next week who just didn't come today. Maybe they forgot. Because with 21 participants, I would love to have at least 5 breakout rooms.
Right.
You know what I mean?
Okay.
Okay, that's fine then. And since it's recorded, I think the recordings can also be forwarded to the TAs as well.
Yeah, so
So
Angela, if you want to figure out a way that we can share the recording from today with the TAs who weren't able to make it, that would be awesome.
Okay.
Yeah, just let me know and we'll email out, or I can get you all their email addresses or whatever.
Okay.
But if you two are good, I'm actually done for today. We're probably gonna, Cyril, since you're here, we need to start working. We need to start working on the drone workshop.
Oh
So
yes.
we need to, I know we had spec'd out a kit, so we need to get that kit and start playing with it and make sure it's gonna work. And you need to make some slides like this for your drone workshop. Do you have something like that?
Okay, yeah, sure. I have something like that, but I would like to see the kit you checked so I can see if I can bring the prototype also in the slide. But I already have a slide on drones.